Hi, we're back with section 4.5, question 5. This has to do with L'Hopital rules and other ways to solve limits that are kind of out of our toolbox at this point. So in this particular case, we're taking the limit as x approaches 0 from the right of the function x to the power of 10 divided by ln of x. And you'll probably look at this and go, how am I supposed to use L'Hopital rule here if there's not a fraction with two differentiable, arguments and, I suppose a numerator and a denominator, because that's the typical way that we use L'Hopital. In this case, though, there's a special form which I actually had to look up myself because I have not used this in as long as I can remember. But it is a pretty clever way to do it. So first we'll start by plugging in the number, because remember L'Hopital is only valid if we end up with 0 over 0 or infinity over infinity for a fraction. And in this case, when we plug in x equals 0, we end up with 0 to the power of minus 10 over ln of 0 is 1. So we end up with 0 to the power of minus 10. And so in this particular case, we have 0 to the power of some number, which we can't really deal with logically. And so at this point, that gives us, I guess this is one of the other, so 0 to any number. We plugged it in, we've got 0 to some number, 0 to the minus 10. And so the trick here is to do some algebra and realize that e to the ln of a function of x is equivalent to the function of x, because e to the power of ln is, those are inverse functions. In other words, ln of e is 1, e to the ln of x is x. So knowing that e to the ln of x equals x and ln of e equals 1, we can tell that these are inverse functions, the natural log and the exponential. And so these are equivalent, but we can now use this in kind of a tricky way to find our limit. So we're going to rewrite our limit, our f of x up here, which is x to the power of minus 10 over ln of x. We're going to write this as e to the ln of f of x, which we chose as x to the power of minus 10 over ln of x. And at this point it just looks more messy, but if you remember, there's something in logs called the power rule, to where we can take anything inside of the log that's raised to the power of something else, we can actually bring that power to the outside of the log and multiply it onto the front. So now we can write this as e to the minus 10 over ln of x times what's left inside is ln of x. And so you'll notice that the natural logs cancel to 1, and what we end up with for a limit is e to the minus 10. And that's how to solve this one. It's a pretty unusual problem to have to solve, but it's always good to have techniques like this. So I hope this was helpful, and I'll see you next video.